This video will discuss problem number 3 from the 2014 AP Stats exam. In this free response question, we've got some tasks that involve probability, some normal distribution logic, eventually some sampling distribution logic. So this one has roots in quite a few of the units that you would study in your AP Stats course. So the problem says that schools in a certain state are going to get funding based on the number of students who attend the school. To determine the number of students who attend a school, one school day is selected at random, and the number of students that are in attendance that day is counted and used for funding purposes. The daily number of absences at high school A in the state is approximately normally distributed with a mean of 120 students absent and a standard deviation of 10.5 students absent. Part A says if more than 140 students are absent on the day the attendance count is taken for funding purposes, the school will lose some of its funding in the next school year. Approximately what is the probability that high school A will lose some of its state funding? So what I did is I defined a random variable. Capital X is going to be the students absent from high school A on that randomly selected day. This random variable X is normally distributed with a mean of 120 and a standard deviation of 10.5. That information was told to us up here. The probability question I'm trying to answer is what is the probability that random variable X is greater than 140, right? What is the probability that high school A will lose some of their state funding, which happens if over 140 students are absent on the day that the count is taken. Now, when you're doing probability questions or when you're doing normal distribution problems in general within your FRQs, a step that you're not going to want to overlook doing is the transition of this as a raw data value, in this case a raw number of students, into the corresponding standardized z-score. So I would take that raw data point that I'm trying to measure to, or past, I guess I should say, subtract the mean from it and divide by 10.5. You have to show this in most FRQs that have a task similar to this. So any FRQs that are going to involve a normal CDF calculation from your calculator, you're going to want to make sure you show this. You don't actually have to compute what that z-score is, but you do have to show that you are transitioning and using that z-score as a bridge from the raw value stated within the problem to the standardized normal curve. Now, the normal distribution that I drew here was actually the normal distribution specific to what I said back here. You see my center is at 120. I'm looking for the area of the upper tail. 140 is obviously above 120, so I'm looking for the space here. So if I do a normal CDF calculation on my calculator to measure the area from 140 onward to infinity, with a mean of 120 and a standard deviation of 10.5, what I end up with is 0.028. So the probability high school A loses some state funding is approximately 0.028. Part B says that the Principals Association would like that the state, instead of choosing one day at random, chooses 3 days at random. They're then going to take the mean number of absences across those 3 randomly chosen days, and if that mean is greater than 140, that's when the school will lose funding. So would high school A be more likely, less likely, or equally likely to lose funding with this plan compared to the plan that we just did some work with back in Part A? Now, what I realized right away here is now I'm dealing with a sample mean, right? So I'm trying to decide if my sample mean, what's the probability that my sample mean is above 140 for these 3 randomly chosen school days. So I defined X bar to be the mean number of absences on the 3 randomly chosen school days. What you see next, randomness, independence, and normality, these are checks that you're probably very likely to have talked about quite a bit anytime you're doing work with sampling distributions. A sampling distribution is going to be approximately normal, have a certain mean and a certain standard deviation, as long as certain conditions are met. The center of the sampling distribution for your sample mean is going to be the same as the mean for the population, as long as it's an unbiased sample, as long as there's randomness. And these are 3 randomly chosen days, so the center of our sampling distribution for our sample mean is going to be 120. Now, we're going to be able to use a formula from the formula sheet the standard deviation of the population divided by the square root of the sample size to determine the standard deviation of our sampling distribution for our sample mean, as long as we maintain independence. And when you're sampling, the way that you check for maintaining independence is that you have not sampled more than 10% of the full population. So we've sampled 3 school days at random. Is that less than 10% of all school days eligible to be chosen within the year? You're likely looking at 180 plus, somewhere around there as the total number of school days. 3 is definitely well less than 10% of all the school days eligible to be chosen. Therefore, we can find our standard deviation using the formula that I just mentioned a few minutes ago from the formula sheet. For a sampling distribution for a sample mean, as long as the population is normally distributed, and in the original problem statement they said that the absences on all the school days of the year are normally distributed, or at least approximately normally distributed. So since all of the absences are normally distributed, the sampling distribution for X bar is going to be normally distributed as well. So what that tells me is that my sample mean is going to follow in a normal distribution with a center of 120 and a standard deviation here. That is the sampling distribution set of conditions. I'm still trying to find what the probability is that the school is going to lose some funding. So what's the probability that that sample mean is greater than 140? Again, I've got the transition to a z-score shown here, right? So 140 minus 120 divided by this new standard deviation that we got up here. I still drew the normal distribution relative to this statement here. So the center of my sampling distribution for my sample mean should be the same as the center for the full population. I'm still trying to find the area above 140 onward to infinity. If I do a normal CDF from 140 to infinity with this mean and this standard deviation, I do get a significantly smaller probability, right? I'm now looking at 0.0005 as the probability that this school loses some state funding, as opposed to what we had back in Part A, which was 0.028. Now, this is not in my handwriting because when I was getting ready to record this, I realized I forgot to answer the question that I was ultimately asked here. So I had all the work and I would have been in pretty good shape, but I definitely have to make a direct comparison back to what I got in Part A. Well, obviously this probability is much less than what that probability was that we got back in Part A, so the school is much less likely to lose state funding with this plan as opposed to the plan that we talked about initially. And then the last part here says that a typical school week is going to consist of days Monday through Friday. The principal at High School A feels that the number of absences is tending to be a little bit bigger on Mondays and Fridays than those days in the middle of the week. So there's a concern that the school will lose state funding if the attendance count occurs on Monday or Friday. If one school day is chosen at random from each of 3 typical school weeks, so this is kind of some more details about that plan that was suggested in Part B. We're going to choose 3 days. Each day is going to come from a different typical school week, so not a 2-day or a 3-day school week, but a 5-day school week, right? 3 typical school weeks. What is the probability that none of the 3 days chosen is a Tuesday, Wednesday, or Friday? Well, if none of the 2 days chosen is a Tuesday, Wednesday, or Friday, what we're really trying to answer here is what's the probability of choosing Monday or Friday? We are in a situation where these events are mutually exclusive. I can't pick one day and have it be both a Monday and a Friday. So I'm going to find the probability of choosing a Monday or a Friday within 1 week by adding the probability of choosing a Monday with the probability of choosing a Friday. So there's a probability of 2/5 or 0.4 that within 1 week a Monday or a Friday is chosen. Now, if we're choosing one day from each of 3 typical school weeks, what's the probability of choosing only Monday or Friday for all 3 of those weeks? I am going to maintain independence with my week-to-week selection, right? Just because I've chosen Monday during my first typical school week doesn't mean I have to rule out the opportunity to choose Monday in my next selection. So because I maintain independence from week to week, I'm going to take the probability of choosing a Monday or a Friday from 1 week, multiply it by the probability of choosing Monday or Friday from another week, and multiply it by the probability of choosing Monday or Friday from my 3rd randomly chosen school week. So if I do top times top times top, I get 8. Bottom times bottom times bottom gives me 125. You can leave your probability as a fraction. You can turn that into a decimal. So there's a probability of 0.064 that no Tuesdays, Wednesdays, or Thursdays are selected using this method. Only other thing to make sure you do here, you can interpret this as saying there's a 6.4% chance that no Tuesdays, Wednesdays, or Thursdays are chosen. This problem is specifically asking for a probability. So this really applies to your conclusion in every part of this. If you are asked for a probability, you need to give an answer that's between 0 and 1. In AP Stats, that's always how we define a probability.